And let's begin with the next session. The next session is about 3 new cases. We will have José Miguel Morea, please, if you want to come, and Jesús Perucho and Pierre Benning. So we will begin with as you know, as yesterday, with littleBIM, bigBIM, and civil BIM. So thank you for being here, José Miguel, y tu turno. Adelante.
Well, good morning, everyone, and thank you very much for being here in the earlier hours of the morning. Well, my complaints in all congresses I've been is that it was all about big works, and this doesn't apply to all professionals because we are not going to work on such a large scale. We are not going to build hospitals. We are going to build large infrastructures. No? So I hope that, therefore, we wanted to thrive another line, another vision about BIM, because we don't want to renounce to that. Since I've heard a lot of presentations, really interesting, I really enjoyed them. And therefore, I am going to spare you all the schemes and graphics that we've already seen, because you probably know them all already. So I'm just going to skip that, and I'm going to focus on what I believe it's really important to go over and over again. When we implement, when we carry out a project, we implement BIM. Ricardo was saying before that consultants ask us for help. So the first thing that we ask is, for what? And at the same time, we ask ourselves, why are we doing that? What for? So that's one of the key questions. It seems that the answer should be quite easy, but it's not. Sometimes when we get the answer, they are answering other questions. And they say, I want BIM because it's the future. I want to implement BIM because it's the new thing, it's the new trend to follow. And that's not an answer to what for. BIM offers many, many things. So what are you really want, or what do you really want to do with that? So we try to redirect people, because we cannot handle everything, that's for sure. We cannot explain all BIM benefits at once, so we have to go step by step. Also, we have to make choices. We have to choose, as in real life. And you have to compromise as well. And sometimes we say that you have to choose a software for each kind of project. Each project requires some specific software. As Ricardo was saying, that's not feasible for companies. I've tried that many times, but a day has 24 hours, so it's just really impossible to learn all the softwares available. So companies are spending money, are spending time. So we said in Spanish that you have to break some eggs to make a tortilla, an omelette. So that will be the same here. And also, we have to define the scope. Also, we have to answer, and when, I'm going to go deeper into that later on. I am going to invent a new LOD, as I'm going to explain later. And some years ago, I read an interview with a famous climber, and they asked them why. Why did he want to climb the top mountains in the world? And he said, because they are there. So the answer to the question of why did he decide to put his life in risk is because these mountains are there I mean, that was the only answer he could give. He didn't know any real reason. He had put a lot of effort. He had risked his life. And I'm sure that if he had asked himself what for, he wouldn't have done that. So the same here applies. Our goal is to design and to build in the best possible way. And also we have some tools to help and to support you in that. But we have to choose. We cannot have them all. We don't want to climb all the mountains in the world. We don't want to use everything at once. So we try to set some realistic goals, and we try to convince people that they have to do BIM, but we try to sell them just the opposite. We try to reverse the situation. We don't want people to have unrealistic goals. So if you go for the real goals, it's going to be easier. We apply the Kaizen method. I mean, it's not that we are into Eastern things or anything, but we discovered it works. It's a simple method. I mean, I'm not going to do the things perfect right away, but I'm going to try. I'm going to strive for it. This method, it's Kaizen, so maybe we should come up with a different name. But we believe that it's convenient, and of course we are going to come up with an acronym, so don't worry. So that's the fundamentals of my presentations. The rest is just, just to be there. So if you are getting bored, go back to this slide. So here you have an example of a very small project that we did. Actually, it's been the smallest work that we have carried out. And I want to tell you more about it. I think that's one of the highlights of the Congress, because an architect is going to talk about a building which lacks a facade. So the client in this project wants to carry out a project. He comes to us. He's from the subway network in Madrid. We say, okay, we are very pleased to help you. What do you need? He says, I need to carry out some works, and I need to know deadline and price, which is really new, right? In the building industry, no one asks for that, really. And yeah, there were some constraints because it was only in 1 month. Deadline was just 1 month, and we had 2.5 months to execute the work. So he didn't care about BIM or anything else. So the only two constraints were time and money. Well, the external agents, as I said, it was a really very little BIM project, but the external agents that took part in the project, there was the design, the building team, and also the property. Of course, I wanted to have some tables and so, because everyone is doing that. So anyway, well, of all these people, no one wanted to know anything about BIM. But we are very self-critics, so we always say that we are only halfway through, and we want to go one step beyond. We think, okay, we are going to get there slowly. Well, the other agents were not concerned at all about BIM. But we did know that without BIM, at that stage of the project, we wouldn't be able to meet the deadline or the financial constraints. So that's what we found. That's not just a random picture I downloaded from the internet. It's a real picture, and that was the information, the data that we had from the project. The project had 500 square meters surface. Actually, it's the Nuevos Ministerios subway station in Madrid. And actually, it was the train station or the subway station where all the suitcases would depart for the airport, the Barajas airport. But these facilities are not in use anymore. So these facilities have been reconverted into a police station. And they told us that the facilities were in good condition, but they didn't know if they worked or no. We just couldn't go there and remove everything for time and financial constraints. You know how the situation is right now in the building industry, so we had to take advantage of the pre-existing infrastructure. So the first step was, what for? Why are we going to use BIM here? So we had many answers, and we had many reasons to go for BIM. So the first thing we did was not to be ambitious. I know there are very top mountains in the world, but okay, let's start climbing just one of them, not all of them at the same time. So we knew that we lacked the time and resources. We had to be less ambitious. I don't remember when this littleBIM name was created. Sometimes it happens when you prepare your PowerPoint presentation. But we talk about roles, users, software maps, and many other things. And we even came up with the idea to write books about it, and we organize it. Of course, we have some diagrams as necessary, but then going back to real life. In real life, diagrams are not so clear, and that's what happens quite often at the work site. The first step to do was to collect the data, the information. We had, of course, some questions solved, but we had to make decisions. And we had one reason there to use BIM. BIM was going to support us in this decision-making process. As you can imagine, space was quite reduced. So that was a huge project, especially because we are architects. We are not facilities specialists. But it was pretty clear to us what we're going to do. And again, you know, a project is a kind of history that you have to narrate to your customer. And we had to explain our customer what was going to be used or not. But it was our own decision. It was very clear to us that we were going, or the elements that we were going to remove or reuse and recycle. And what was the final objective, the final goal? Why are we doing to do that? Well, to get there. I know my time is almost over, so I'm just going to speed up. You know, from all this story, I have to tell you that the project was completed in 1 month, the works in 2.5 months. There was no budget deviations, that was €0. And that was also a good thing for taxpayers. Not everything is about BIM. BIM is a means. But I have to tell you that in this specific case, without BIM, the project wouldn't have been possible. And I'm very sure that in that case, BIM was essential. And as Ricardo was saying before, he was talking about SMEs. We are a very small SME. So I would say we are micro business. But we actually do things thanks to technology. Technology allows us to go a bit further. And even though these technologies can be implemented in big companies, they are important for small companies as well. However, in this whole process, we had to compromise. I said that before already. But indirectly, we had we achieved some things that hadn't been foreseen. And that was quite surprising. Something which is not on the slide was that if we, neither the constructor or the client or the other agents were interested in BIM. We actually make these agents interested in BIM after the project. When they saw the results, they came to us and said, okay, how did you get that? How did you do that? How did you manage to meet all the requirements? Because, I'm a chief of works and I know what a planner does, and I know it's very complex, and they don't always achieve their goals. I mean, how did you do that, right? And how come that you are telling me where am I going to have problems in the future? I mean, it's the first time that I see something like that. And in that way, we made the other agents become interested in BIM. That was not our goal, but it was an indirect goal. So if you want to climb a top mountain, you have to climb first a 2,000, 3,000 meters high mountain first, before you go for the really big ones. As a conclusion, I don't want to compromise BIM. I mean, I really want to use it as a small company. After 10 years working with that, I'm not willing to go back to square one. That's BIM allows me to go one step beyond, and without this technology, I cannot carry out my work. And, many of the attendees here are architects or surveyors. And according to Spanish legislation, professionals who work on the architectonical project, it's compulsory for us to define our projects have to be 100% defined in terms of financial and design issues. And I'm sure that you agree with me that there are some things that we cannot solve. And it's thanks to the collaboration with the other agents, we are able to solve them now. We are assuming some problems right now that we didn't have in the past. We are thinking about stuff that in the past was not an issue. We are using tools that allow us to comply with the current legislation. And as always, we have to ask ourselves, what for? Of course, it's not only what for, but also how. And therefore, we wrote this small guide so that people can answer their own questions, right? And it's not a guide that you have to follow step by step, but it's going to redirect you. And the second edition is going to be published very soon. I've got some copies, and on March 16th at the Quantity Surveyors Associations in Madrid are going to hold an event where this other document written by a colleague is going to be presented. And we are going to present, or we are going to have a course on BIM models. As a conclusion, I would say that the answer, it's not that fundamental, but it's very easy, at least, to find one answer. I'm sure that as a planner, as a constructor, we will be able to find at least one good reason to the answer to the question, why are you going to use BIM? It doesn't mean that I am going to use that in one stage of the process or for one specific goal. If you are going to take advantage of it, then go for it. And you'll see that the other agents, finally, are going to grow an interest for that, because you are having success and they are transmitting this idea to the rest of the industry. Thank you very much.
Muchas gracias, José Miguel.
Thank you very much, José Miguel. Now we're going to talk about bigBIM. Sometimes size matters. And this is one of the cases because Jesus Perucho is going to talk about it now. Jesus Perucho comes from Foster & Partners, and he is in charge right now of the largest world airport. We'll see how big it is, and we'll see how it would be really difficult to coordinate this airport work without BIM. We have here Jesus Perucho. He worked in several projects in Spain and Haiti, and one of his last projects was for ADIF, working on the high-speed train called Aramine project, which was a high-speed train that is going to connect the Mecca with the Medina in Saudi Arabia. One of the guest countries is the United Kingdom. I had thought of inviting Norman Foster, and Jesus said, you don't need to do that. I'm his BIM coordinator. And I thought, well, of course, then we have the best of the best. So, Jesus, I give you the floor.
Thank you. Thank you very much. Thank you for the invitation, for coming here today. I'm going to talk about this Mexico airport. This is the building. There was a competition, and Norman, the team made by Foster and Partners and Free, which is Fernando Romero, is a Mexican architect. We won this competition, and we had to do it in BIM. This building is the whole airport is made by 3 buildings, which is the passenger terminal, which is this building in red, like an X of Mexico, and then we have as well the GTC, which is like the car park, that green circle there, and we have to do as well a control tower and a metro station. So a year ago, they told me we have to do this building in BIM, and I said, no problem, let's do it. So we just started in a very basic way. I'm sorry I cannot bring any real images of the project that we are doing now, because we are now in the latest stage of DD. We have to finish the project in 1 month, so we are and the project is confidential, so I cannot show any real renderings or images. All these images are already public on the internet. In here, we will see the size of the building. The only thing, I'm not going to talk about anything new. I'm not going to say anything new about BIM that you don't know, just the size. The only special thing about this project, apart of the geometry and the bespoke design that it has in all the furniture, we will see a bit of it, is the size. This is our building, the building we are now. If we go farther away, this is the building. So if you look at this image, I will go now talking about the volume strategy we have followed to divide the models. If you just look one of the legs, the blue building that we are now, and all the pier, that is one of the legs of the building. That is the smallest part that we are working now, because at the beginning we used the whole terminal as not one model, but when we started we made one model for each level. So we had like four models for level 1, 2, 3, and 4, and then another for basement. Well, we'll talk now, but keep this image in mind. So the smallest architectural part is one of those legs. So the lead architect is Foster & Partners and Fernando Romero, and as well the engineers is Arup in New York, and NACO, which is Deutsch architects specialist. We are using a multi-platform software. I mean, we are using some different softwares. Mostly the modeling, 3D modeling in BIM, we are using Revit, but most of the design is done in Rhino and Grasshopper. We'll see all the complex geometry of the roof is done in Grasshopper and then exported in Rhino. We'll see now the workflow. We're using as well Navisworks for class detection, a bit of AutoCAD, a lot of MicroStation, a bit of Advanced Steel, and many other softwares as well, and many plugins. We are using lots of plugins. There's the terminal, we have the control tower, they have different coordinates, positions, of course. This is the initial volume strategy we followed at the early stages of the project. As I said, we have split the building by levels. So we had a file for level 1, 2, 3, 4, another one for the basement. Then we had a file for the cores. Then we split it in cores back of the house and front of house. Well, and then another file for the fixed link. And then we were receiving as well the models from the engineers. So we had, for MEP, we have 4 different models, one for each discipline, and then one for the structure. They divided into 6 zones. So, well, in general, we had like around 20 models for this. These are more or less the models. So one per level, and then so around 20 models. We were as well checking the size of the models. None of the models were higher than 80 megabytes in general. Most of them, they are 50 megabytes. So it was very manageable. And then for now, for DD, for the documentation, design documentation, we followed the strategy that was followed by the engineers, that was dividing into 6 zones. You remember the first image we show of the pier of the building? That there are 6 zones, so one for each of the piers, and then two zones in the center. So from A, B, C, D, E, F. So for each of the zones, we have the same that we had before. So we have one file for level 1, level 2, level 3, level 4. Then one for the fixed links, one for the cores back of the house, cores front of house. And then we have the structure as well as only one file. And then we had the same MEP files that they are only one single file for the whole building. So they are not divided by zones. And then we have as well the roof. The roof is one really big challenge in this project. We'll talk about this now. If you have seen in the first images, you know, a part of the size of the building is the geometry. This roof is really complex. And for us has been really, for me, has been really a challenge to get this geometry into Revit. This roof is designed in Grasshopper. It's a complex graph that it's been designed at Foster's. Then what we do is we get, they can export in different ways. They export it in Rhino. And then when we got the Rhino file, well, actually, this roof is made of a spatial structure and as well the skin. I mean, the external skin that is we call it the mesh, which is the roof. I mean, to protect against the water and everything. So we at the beginning we used 2 different workflows for because one of is a surface and then the other part is a structure. So for the paneling, we followed our workflow with Dynamo, and then with an adaptive component, we were converting it into Revit. And for the structure, we used a workflow through Advanced Steel, and we were converting each of the lines of the mesh into a structural bar. So we got it into Revit as well. So we could use this geometry into our drawings, I mean, into our sections and in our floor plans. And now, in the latest design stage, pre-construction design stages, before we had to divide the whole roof into 20 zones, because in order to make manageable sizes of files, because, I mean, it was crashing. I mean, you can imagine, sometimes Revit crashes, sometimes Dynamo crashed. With this design, we had to work together with Autodesk to get this roof into Revit. We gave them our models, our drawings. It crashed for them as well. They had to recode, I mean, Dynamo they gave us a new Dynamo code. We've been working together with them a lot, and we have been pushing the boundaries of technology with this roof. And for Autodesk, this project is going to be the benchmarking for next year in volume size, because for them as well it's a challenge to get this roof. So after they got they were working on this roof as well with the new changes they made in Autodesk with Dynamo. As well, we divided into 48 zones the roof, and then we could work only with Dynamo on Grasshopper. So we could divide this roof into layers, and we could specify different sizes of the bars. So finally, what we've achieved to do is to get all this geometry, which has all the nodes with the spheres, all the geometry that you see in Revit elements, but for the full size of the roof. So we are using it now in our drawings. As well, we are using Autodesk Navisworks for clash detection. We are having weekly meetings with the internal, with the team, with the consultants. We are sharing the model every week. We are having meetings with them fortnightly. I mean, we are doing like a regular BIM workflow with lots of coordination. As well, with the engineers, we do clash detection reports. And this is, the good thing is that the team, it's a big team of people. It's around 80 people working on the project, IT architects. But the good thing is they open themselves the Navisworks. They check the area they're working on. They find clashes. They talk directly with the engineers, so we don't have to be like on top of them. So it's been a really useful tool, the Navisworks, for us. The BIM for this project as well has been really important because of the information management. It's really a huge project, and we are using lots of information, lots of drawings, lots of rooms. We are using, of course, the information exported from the models to Excel and to the Rofus. We are doing room data sheets for 4,000 rooms, so a specific sheet with all the information about MEP and dimensions and floor plan for each of the rooms. So we have to use many other softwares like the Rofus. As well, the model is used for analysis, for structural calculation, and the structural model is coming from it. And it's very, very important as well for the MEP, because they get as well from our architectural model. They can generate the rooms and can get the power areas, the fire protection areas, everything. They got it from our model. We are as well making all the drawing production from the models. We have more than 5,000 drawings, and we are doing everything from the Revit. So we have around 15 sheet files. Each of the sheet files is linking all these partial models. Now we have, around 120 models for the whole building without the roof, because only the roof is around 200 models. So we would have around 320 models for everything, for the whole model. And this is only the terminal, because then we have as well the control tower, and then we have as well the GTC and the metro station. And so, yeah, I'm just talking about the terminal building. So these models that are the sheet files that are linking all these models is for each of the packages. So we have a package for the GAs, for the general enrichment plans, other for the sections, other for ceilings. So yeah, all this requires lots of coordination, lots of communication between the team. It's a hard work. Yeah, this is one of the 1 to 100s scope boxes of the terminal. We get 80 drawings only for one level, for one of the levels. So if we want to print only the 1 to 100s, it's around 320. This is R key is American size, but it's like a DNA 0. So it's only for, we would get 320 drawings for it. So a sample of one of the drawings. So we're doing general arrangement floor plans and detail arrangement sections and drawings as well from the model. As I said, I cannot show any renderings or images, but I'm just showing you some images, snapshots from Navisworks. There's lots of bespoke design of fixed furniture, like check-in counters, which is this design. This is all the roof. Get into Revit with the process I showed you. This is the view from level 4 going to the retail area. And a view of the model. And that's it. Thank you very much.
Muchas gracias, Jesús.
Thank you very much, Jesus,
por enseñarnos cómo
for showing us this huge work that you are carrying out. So now we are going to talk about BIM engineering, and therefore we've got Pierre Benning from Bouygues Travaux Publics.
Pierre Benning is a civil works engineer in charge of technical computing at Bouygues TP. He's an expert in collaborative work processes in BIM environment, and he participates in the specifications of tools for simulation, information sharing, and technical data management. So he contributed to the European project IMPRO and to the French national project Communique, and is currently one of the leaders of the Open Infra initiative for Building Smart, and the new French national project MINT that will be shown later on. So thank you for being here, Pierre.
Bonjour mesdames, bonjour messieurs. So my name is Pierre Benning. I'm working at Bouygues Construction in France in the civil works division. I'm a civil engineer, and I'm currently IT manager in charge of spreading BIM, civil BIM, into my company. Today I will present you one infrastructure, one linear project where we are using BIM for design and construction. This project is called L2 Bypass. It is located in Marseille, in south of France. It's 11 kilometer long urban motorway linking the A7 motorway in the north of Marseille to the A50 in the south east of Marseille. It's a 30-year public-private partnership, and the green part. So the green part will be delivered this summer, and the orange part will be delivered late next year. You may know that the first thing to do is to elaborate a BIM execution plan, a common guide in order to implement BIM among all the different partners. The first objectives are to define the BIM users with a project management team, and concerning the L2 project, we define 4 objectives: the data consistency, the coordination of the different disciplines, support for external communication with inhabitants and the local representatives, and some specific construction sequences. One paramount work is to structure the data we will use. And so we have to consider a spatial organization by zone, by site, by interchange, and so on. A systemic organization by discipline, the different networks, the road traffic signs, the traffic safety, and so on. The level of development or levels of details we need in each phase of maturity of the project. The data delivery milestone expected from each design department, and of course the data responsibility of each partner. The goal is not only to follow the progress of the design and the construction, but also to anticipate the collisions we want to detect between the families of objects. So you can see the first thing that we have to do, an Excel sheet It's a very boring work, but it's essential for the management of the BIM process. And so after that, you have to wait for the 3D data. And sometimes you are waiting for a long time because you are expecting data in 3D, but you receive only data which are directly available with less efforts. So it's always, most of the time, in 2D. You expect the terrain, the existing structures in which you are working with, the structures to build, and you are also expecting the roads, the local roads, in order to link your project with, the equipment to set, the complete networks existing and to be set. And what we got, a lot of 2D data in DWG format or PDF files with no geo-referencing information, without talking about the GIS data, only in 2D without elevation. So, and again now, we have to rekey in 3D all the data we got in 2D. We made also a LiDAR campaign to get 3D points of existing structures. Of course, we specified a complete object structure in order to get the maximum of smart data to incorporate in the 3D model. It's a very, very important point if you want accurate data from the early start of the project design. Now, let's talk about the processes, the BIM management. First of all, we are using a lot of different softwares, a lot of authoring tools, AutoCAD, Civil 3D, Inventor, Revit, Covadis, and so on. And most of them are Autodesk software packages. And 2 3D aggregators, Virtual Map and VDC Explorer of Villanova. Of course, we faced a lot of interoperability concern, and we don't have any magical wand, so you have to keep calm and roll up your sleeves and take the data that you have. Then you have to build a good and interdependent BIM management team. You have to identify the BIM champions, the BIM managers, BIM coordinators, BIM contributors, and so on. And first of all, you have to establish trust among the partners beyond contractual links in order to facilitate exchange and collaborative work. You have to establish trust. You have to define accurate workflows, redefining the status of data during the validation process. And you can see here an extract of the model review workflow inside of where collisions are identified and managed inside the same discipline. And the project review workflow where important decisions have to be taken by the project management team. In the model, you have to follow up the progress of the data. Identifying the source of each display data. So if you point out on the wall on the right, you can get information specifying XA. Here, XA. That is to say that this wall has already been carried out. So you can follow directly in the model the level of development of each object or families of objects in the 3D model. And so, where are we today? We have a complete 3D model divided in 2 sections, one for the north part of the project and one for the east part of the project. So you can see where we are today in the L2 project. There is a 2,000 meters corridor where we can see, you can see, all the existing buildings, the footbridges, the horizontal and the vertical road traffic signs and so on. The new roads, the new landscaping. So a part of this model has been carried out. A lot of things are still in progress, in design progress, because for the landscaping, a lot of architects are still working. You can see parkings, here some gardens, some promenades, some games for the children, and so on. Here, a very complex interchange with a lot of security fences, barriers, panels for alert traffics, and so on. So if you point out each object, you can know what is already carried out, what is only designed, what is validated, and so on. And so it's the complete model of the east part of the project. You can see here on the left some noise barrier and so on, where we have made a lot of simulation for that. Everything in the 3D model, because all the design, all the objects are very accurate, and it's not exactly what we have seen in Lumion, where you can move and change everything where you want. Here you can't change everything, because here all objects has a very accurate position and so on. So here it's a cut and cover, a long cut and cover. So all the project is buried under the ground. And here we come to the end of this section with a viaduct. So that's the end of the video. Thank you, and have a good day. As a conclusion, we have a long way in front of us. We have a lot of points to ponder. The contractual innovation to work in a more collaborative and trusty environment involving all partners. The generalization of processes demanding intuitive and user-friendly interfaces. The development of new competencies in order to anticipate data structure, to support design teams, but also to improve our current and experimental processes. And at last, we have to take the leadership of national and international research initiatives to be proactive in front of software editors who try to impose us their file format and their working processes. I invite you to take a look at the BIMgeneration.com website, which explains some BIM ambitions and how reconstruction considers and tackles them. Thank you.